So today we're going to learn about radians and degrees, which is just two different ways to measure angles. Just like Fahrenheit and Celsius are two ways to measure temperature, radians and degrees are two ways to measure angles. We're comfortable with degrees, right? We get degrees just like we get Fahrenheit, but radians is going to be like Celsius for a bit. It's just going to be like feel a little different to us, but we can relate to it because we understand degrees. First, we want to go back over the quadrants, right? And remember that the quadrants go 1, 2, 3, 4, right? X, Y, and axis, right? And then here for trig angles, all trig angles are going to start here on the x-axis. If the angles are positive, they're going to open up. If the angles are negative, they're going to open down. And so, for example, if I have a 30-degree angle, we just want to draw this angle. It would start here. We call this the initial side of the angle. And it would open up here. 30 degrees would end up in the first quadrant. If I have a negative angle, that's going to open down. So a negative 150-degree angle is going to come down here, actually into the third quadrant. So a negative 150-degree angle would be in the third quadrant. What about a 720-degree angle? We know if we go around the circle once is 360. All we would do is go over the circle twice to get 720, and 720-degree angle is on the x-axis. A negative 210-degree angle is going to open down, and it's going to end up here in the second quadrant, negative 210 degrees. And I might recognize that a negative 210-degree angle is the same thing as a positive 150-degree angle, right? Because they add up to 360. So in general, we know if I take the circle and I start here, right, and I go around, this would be considered 0 degrees, 90 degrees, 180 degrees, 270 degrees. And if I get back all the way around, the circle is 360 degrees. In trig, we talk a lot about a unit circle. A unit circle has a radius of 1. And you might remember that the distance around the circle is the circumference of the circle. Do you remember the formula for circumference? You are right. Circumference is 2 pi times the radius. But if the radius is 1, the circumference would just be 2 pi. So 2 pi radians basically is the distance around the circle in radians. And 2 pi radians is going to equal 360 degrees. We don't have a symbol for radians, like we have a little circle for degrees, but we don't have a symbol for radians. If 2 pi is equal to 360 degrees, what would 1 pi equal? You're right, 1 pi would equal 180 degrees. And this is what we call our conversion factor from degrees to radians. So 360 is 2 pi, and then 1 pi is 180. You could also fill in like maybe 90 degrees. Anyone know what 90 degrees would be? You're right, 1/2 pi. If 1 pi is 180, 1/2 pi, or what we call pi over 2, is 90 degrees. And then 270 degrees is 1.5 pi, or we call it 3 pi over 2 radians. So we're just kind of getting used to, those are some benchmarks to have us get used to the difference between degrees and radians. If you have an angle in degrees and you want to change it to radians, the best way to do that is to multiply by pi over 180. This is what we call the conversion factor. So if I take 30 degrees and I multiply it by pi over 180, I'll say, okay, 30 goes into 180 6 times, and that is going to be pi over 6 radians. If I have a negative angle, that negative is just going to stay with us, negative 150 times pi over 180. And then I'm just going to reduce my fraction, right? 30 goes in here 5 times, 30 goes in here 6 times, so it's going to be negative 5 pi over 6. And right now these answers don't make a lot of sense, but when we start to put them together, they're going to make a lot more sense. Like even 720 degrees, you might be thinking, well, wasn't 360 2 pi? So shouldn't 720 be 4 pi? And yes, it is. Negative 210, again, if I multiply by pi over 180, I'm just going to reduce my fraction. 30 goes into each of those, negative 7 pi over 6. So that's changing from degrees, or from degrees to radians. If I want to change from radians to degrees, I'm going to multiply by the reciprocal, 180 over pi. Now some of them we already know by heart, like we already know that pi over 2 is 90 degrees, but that is the equation, I guess, that would show us that. We might not know 5 pi over 6, so I would multiply it by 180 over pi, see the pi's canceling, and 5 times 30, 150 degrees. Here with the negative is just going to hang out there. I'm still going to multiply by 180 over pi. The pi's cancel, negative 120 degrees. And then negative 5 pi over 12, 180 over pi. The pi's cancel. Let me say 6 would go into each of those, and then, 15. And isn't 15 times 5, 75 degrees. So that's changing from radians to degrees. So now we go back to our circle and we're going to kind of fill in the ones that we know. So we know 0 degrees here, 360 degrees. We know this is 90 degrees, 180 degrees, 270 degrees, and then 360 degrees. If I change those to radians, 0 degrees is 0 radians, 360 is 2 pi radians. We already talked about how 180 degrees is pi radians. Half of that is pi over 2, and 1.5 is 3 pi over 2 radians. Now, we're going to start to introduce what we call our 16 special unit circle angles. We have 16 angles, and these angles are going to come in what we call families, right? These families have something in common. So here's my first family, actually my second family. The first family was 0, 90, 180, 270, 360 is going to be considered a family. And now we have 45, 135, 225, and 315. Why are these angles considered a family? You're right, they're each 45 degrees away from the x-axis. So if I subtract 45 from 180, or add 45 from 180, or subtract 45 from 360, I end up with what we call the 45 degree family. So that reference angle is how many degrees the angle is from the x-axis. So 45, 135, 225, and 315 are all 45 degrees away from the x-axis. If I think about this, I can multiply by pi over 180 each time, but I might be able to more intuitively think, well, 45 is half of 90. Half of a half is a quarter. And basically what I've done is split this into quarters, so to speak. So 1 quarter, 2 quarters. This is going to reduce to 3 quarters, 4 quarters, 5 quarters, 6 quarters reduces, 7 quarters, and then 8 quarters gives me 2 pi. So here's where we're starting to see some connections. It's not just random, right? You're going to see kind of this consistency between families. So when you get to the homework, you're going to add on what we call a 30 degree family and a 60 degree family. I'll fill in the numbers here. I won't have room to do all the radians, but these are the numbers that for the next long time are going to become very familiar to us. So what I'm doing here is basically filling in the 30 degree family and the 60 degree family. And as you do the homework, it'll be more clear to you what those are. Radians and degrees.